The first reason it's useful to be able to do a Laplace transform is because it's easy to find the output for any given input once you have the Laplace transform. In this video, I'm going to be showing you how you go about finding the output for any given input. In order to do this, we first have to put the equation into a particular form that we refer to as a transfer function. A transfer function is an equation that has the form the output divided by the input equals something. I'll show you how to do that with this equation that we have up here. The first thing I need to do is I need to gather all of the terms that are multiplied by the output y of s together on the left-hand side of the equation, and I need to gather all of the terms that are multiplied by the input x of s on the right-hand side. Now, all I have to do is divide both sides by x of s to get the x of s over here, and divide both sides by everything that's being multiplied by y of s over here. To make it a little bit clearer what I'm doing, I'm first going to factor out the y of s from the left-hand side. Do you see now how I can get this equation to be in the form y of s divided by x of s is equal to something? I'm going to divide both sides by x of s, and I'm going to divide both sides also by this entire term that's being multiplied by y of s. And what I get out looks like this. This is now in the form of a transfer function. I can tell that it's in the form of a transfer function because on the left-hand side I have the output signal Laplace transform divided by the Laplace transform of the input signal, and that's equal to something on the right-hand side that has only constants and the variable s. Now here's how the transfer function makes it easy for us to find the output for any given input. In order to find the output, all I have to do is come up with an equation that represents the input signal and multiply that equation by both sides of this equation. Then I will have y of s alone on the left equals this term times whatever my input signal is. Now, as it turns out, each different kind of input signal has a defined Laplace transform. Remember that the input signals that we're most interested in are the impulse, the step, the ramp, and the sinusoid. We can find out what the Laplace transform is for each of these signals by simply looking them up on a table. We could also derive them, and we may do that in a later video, but for now, let's look at what these things are. The x of s for an impulse is just the number 1. The x of s for a step is a, the value of the step, which is often the value 1, divided by s. A ramp then, this should be an a here, is a divided by s squared. And a sinusoid input has this term for its Laplace transform. Let's take a look at how we can use this information to find the output for any given input. Let's start with the impulse. If we want to apply an impulse input to this system that we have up here, all I have to do is take both sides of this equation and multiply them by x of s. And if we have an impulse input, the value of x of s is going to be 1. That means that my output, y of s, will be equal to this term over here. Now, to find the time signal represented by this, we have to use a process called the inverse Laplace, which we will be learning later on. For now, we'll be seeing in class how we can use this transfer function to find the output for any given input. We can use MATLAB to do the inverse Laplace of this equation in order to give us back the value for y of t. Now, what if we wanted to apply a step input instead? In order to find the output for a step input, instead of multiplying the right-hand side of the equation by 1 for the impulse, we would multiply the right-hand side of the equation by a over s for the step. So this term that we just found, this tells us the output to an impulse. For the step input, we would instead multiply this by a over s. That would give us y of s is equal to a s cubed and this equation tells us the output to a step. We could do the same thing to find the output to any kind of an input. For example, let's suppose we want to find the ramp output. To find the ramp output, I would use x of s equal to a over s squared. So down here in the denominator, we would have s to the 4th. And this would tell us the output to a ramp. Previously, the only way we had to find the output to a given input was to actually build a simulation with a time step. Here, we can find analytically the equation that represents the output by simply taking the inverse Laplace of this final equation after we've multiplied the system by the Laplace transform of the input that we want. I'm not going to go into how to do the inverse Laplace right now because I think that's too much material for one day. For now, you should understand that the Laplace transform makes it easy for us to find the output to any given input because all we have to do is first find the transfer function, which is the output divided by the input, And then we have to multiply both sides by the Laplace transform of the input signal that we want. And then all we have left to do is find the inverse Laplace.